So this week we finish up chapter 20. We're talking about asteroids and comets, which is section 5. And then section 6, the last section, is on space travel. And as we talked about yesterday, next week, the end of this week and next week, you are going to be working on a project of your choosing that either is about some place in the solar system, or it could be about stars or galaxies or the search for extraterrestrial life, or some of the space exploration missions that we have had, such as the Apollo program, space shuttle, any of those things. Yes, you can do black holes. I will have an assignment description for you probably tomorrow, but definitely by next week. You can do it on any astronomy related topic. Keep in mind then, next week, no, the week after, during TCAP, you will present your fabulous things that you learned to the class. So I'd highly recommend doing a PowerPoint type presentation so you can do that. So this week, asteroids and comets. And you read about this yesterday, and let's talk a little bit about the difference between asteroids and comets. A comet could be called a dirty snowball the size of a mountain. The big difference about comets compared to other things in our solar system is that they are made of ice and rock. So they're mostly made of ice. Most could be water ice, could be dry ice. And the comets, they're in our solar system because they revolve around the sun. Solar system, right? Sun system. So the other thing about comets is they have a very elliptical or oval-shaped orbit. So here, in my incredibly beautiful and accurate picture, there's the sun. And this right here would be the comet. The comet orbit would be like this. And this would be a more regular planet orbit here. So you can see it's very different. And when you watched the Tim and Moby yesterday, the Brain Pop, they talked about some of the comets, like Halley's Comet has a period or an orbit of 76 years. Some of them have periods that are over 100 years. So they might only come by the sun on very, they'd only be seen once in a lifetime. And they go out, most of them go out way past where Pluto is, here's Pluto, to an area called the Oort cloud, which is beyond, kind of the edge of our solar system, where there are many comet-like objects. So they come from the Kuiper belt, and strangely, this is named after a person. It's called the, oops, make that an I. It's pronounced Kuiper belt. And Kuiper belt or the Oort cloud. And again, when we talked about Pluto and Pluto not being a planet anymore, we also talk about those things being Kuiper belt objects. This is a picture from the textbook. And here on this picture, we have the comet going around the sun. As the comet goes around the sun, you will see the tail of the comet doesn't always trail behind the comet. The tail of the comet always points away from the sun, because the sun and the radiation and the solar wind kind of goes out in all directions. And what it does is it melts the comet, and it makes it, basically blows it away from the sun. There are two tails, and one is more the water vapor tail. And I think we've got that on the next slide here too. So it does actually melt and get smaller as it gets closer to the sun. See if I've got more comet stuff here. Nope. Okay. So the two tails, one is more the water and one's more the dust. Questions about comets? Yes. It's a flipped lesson. Recording it right now. Yes, kind of. You could do your project on comets and talk even more about it. Let's see. And asteroids are too small and irregularly shaped to be planets. They are lumpy, they are small. Most of them are found in the asteroid belt, more than 100,000 of them between Mars and Jupiter. The mass of all the asteroids together is still too small to be a planet. Why is the asteroid belt there? Well, we don't know. Could be a planet that never formed or was destroyed or whatever. The largest of the asteroids, again, is in Brain Pop yesterday. One of them is named Ceres. The largest ones are bigger and rounder than Pluto. Um, some have more elliptical orbits and come in closer than the Earth and then back out. But most of them are in that asteroid belt. But asteroid's just a big, rocky, unusually shaped chunk. Um, and probably many captured asteroids make up the moons of Jupiter. The Kuiper belt is out past Pluto, and so we have this picture. We've seen this picture before. This is the Kuiper belt. Here's Pluto on its weird elliptical orbit here, also known as the Kuiper belt object. There are so many things out here, and as we talked about, this is where Pluto ended up being demoted to a dwarf planet because there are so many other things out there, many further away, many bigger than Pluto, but it's just so far away that we did not know a lot about it. The Oort cloud, so this is kind of a belt-shaped orbit thing. The Oort cloud is a more spherical region, and that's where comets come from, and it's out there as well. So those are the things at the very outer portions of our solar system. All right, the last chapter, the last section in this chapter is about life and what life needs to survive. We're going to go over this real briefly, and then you can finish your worksheet on it. So, as far as we know, Earth is the only place in the solar system and the only place in the universe that has life, which is interesting, right? Because as vast and huge as the solar system is, you would think that there must be life somewhere. But there's a couple things. One is the universe is very big and we haven't explored all of it. And as you can tell from even just how much we've studied, even with telescopes, we can't see everything. Secondly, there's a whole thing of time, right? The universe has existed for probably about 12 billion years, as near as we can estimate. The Earth has been around for 4.6 billion years, and humans have been around for about 5 million years, right? And that's just kind of humans like, but yeah, in terms of the sophistication being able to look and communicate, yeah, then you're talking maybe 1,000 years. So we are this tiny, tiny blip in the whole universe. So it could be that there's other life somewhere. We just haven't found it. The other thing, of course, is when we look at life, we of course look at life as we know it. So thinking back to last year, 7th grade life science, what does life need to survive? Yes. Okay, so food and water. Wait, we got water. Water's definitely, so we got to have the habitat with food and water. Does all life need oxygen? No, because of course plants don't. What do we use oxygen for? Yes. And what do we use oxygen and food for? Yes. Remember 6 characteristics? So you need an energy source. A habitat is where a living thing finds its food, water, and shelter, right? Plants, of course, are using carbon dioxide to make their energy. Water, food, shelter. Okay? We need an energy source. What else do living things... A good way to think about it is, we know there's nothing, as far as we know it, living on the moon. Why not? What is not on the moon that you would need to live? Yes? Yes, an atmosphere. And the atmosphere is providing us with, oxygen, carbon dioxide. But what else does the atmosphere do for us? Yeah. What else were you going to say? Yeah, so we need liquid water. And so part of the problem, yes. Yeah. And the other thing it does is it traps the heat with the greenhouse effect. And a lot of times we think of the greenhouse effect as being a bad thing. but with no greenhouse effect. Remember, the moon or the planet Mercury get extremely hot and extremely cold. And as far as we know, life can't live under those conditions. And so you have to have the right amount of atmosphere so it's warm enough, but not too warm. Venus, too warm. The other, Mars and Mercury, way too cold. And so we need moderate temperatures so that we can have liquid water. Not too hot, not too cold. We need water, food, shelter, those sorts of things. Now, um, the Goldilocks conditions are kind of funny, right? Because you've got Venus, well, so Mercury is extremely hot and extremely cold. There's no atmosphere. Extreme hot or cold. It's too close to the sun, right? Then you've got Venus. What's it like on Venus? Yeah, a very thick atmosphere. It's extremely hot. And also, there's sulfuric acid and that kind of stuff. Thick atmosphere, too much volcanic activity, too hot. Then you've got Earth. And let's go to Mars, and we're going to come back to Earth. What's wrong with Mars? Too cold. It actually doesn't get that hot on Mars. It's too cold. There's also too thin atmosphere. Oops. Oh, that was annoying. And so thin atmosphere, and so you've got it's too hot, it's too cold, and so Earth, of course, is just right. Right? And so it's kind of funny, but they call it the Goldilocks conditions. Remember Goldilocks and the Three Bears? And so it's not too hot, it's not too cold, it's just right, which is kind of silly, right? But it's a good way to think about it because Earth is at this interesting distance from the sun that it's not too hot, it's not too cold. We can have liquid water and water vapor and ice all in the same atmosphere because there's the right amount of temperature and pressure. So you'll hear on the news that we found a planet that's Earth-like and might support life. All it means is that they found a planet around a star somewhere that seems to be at a similar distance and it's a similar size that it could possibly have an atmosphere and a temperature that could possibly support life. So they say they found an Earth-like planet that could support life, but it's really kind of a stretch and not nearly as, you know, exciting as they make it sound on the evening news. Yes. So next week we will talk a little bit more about the universe as a whole and the Big Bang Theory, but there's a whole lot of things too, like where did the first life come from? What happened right before the Big Bang, which was the explosion that makes everything move apart? We just don't know, right? And that's why some astronomers spend their whole lives studying these things. I think it's a little bit, I don't know. It's not what I want to study with my life, but some people, it's really fascinating. Okay. All right. So extraterrestrial life. So um, Mars, the more we study Mars, the more we see that it could be that life maybe existed on Mars at one point, because it does look like there was much more liquid water than there is now. There's evidence in the rocks, there's evidence in water ice just below the surface, and we're finding those things. And the newest mission, we'll watch this, several parts of this NOVA special called it's about Mars and the Curiosity rover. But the reason they sent it where they sent it is because it is the most likely place that they might find life. We don't know what happened to Mars's atmosphere. Mars probably had more of an atmosphere and clearly had volcanic activity and liquid water in the past. We don't know why it doesn't anymore. So something happened there. Could there have been life? Sure. Was it, plants and animals? Probably not, because we've seen no evidence of that. But you remember from studying last year, and it's up on the board here for my 7th graders, remember the archaea, tiny single-celled bacteria-like things that live in extreme environments, extremely cold, extremely hot, acidic, hot springs. So life somewhere else, could be archaea or bacteria, and you're not going to see that unless you look really, really close. It could be plants or animals that don't look anything like us. You watch science fiction; they have all sorts of ideas of what it could be. Um, Europa, we talked about a little bit with the planets. Europa, some of the other large moons do seem to have liquid water, and so maybe there's places that life could exist. We haven't found it yet. And then extra solar planets, that's what I was mentioning. Those planets that are around solar systems, or in solar systems around other stars, very far away. If you choose, I would love it if somebody next week chooses to do the Voyager programs. The Voyager programs, we talked about those, they've both since left the solar system. The Voyager programs carried these gold records on them with some sort of record player. You guys know what a record is, right? So way before the CD technology, right? No, but the thing is it has pictures of humans. It has saying like hello in all these different languages. It explains about Earth and it shows where Earth is. It has samples of music. It has voices of school children, and it has all of this stuff that was sent on these probes just out into space, so that someday, possibly, someone, some sort of intelligent, finds it, right? And comes back and eats us all. I mean, who knows? But there's lots of good science fiction saying what if. But anyway, so lots of good stuff to study, like Alien. So I'm going to leave it here. And we'll get all of us exploring other things.